Welcome to Lesson 3.7, Assessing and Mitigating Web Vulnerabilities. In your Candidate Information Bulletin, we are in the Security Engineering domain. We are in Key Area of Knowledge F, which is to assess and mitigate vulnerabilities in web systems. Our topics are going to include web vulnerabilities, the OWASP Top 10, injection flaws, broken authentication and session management, cross-site scripting, deploying secure code, and looking at an application development policy. Let's start with talking about web vulnerabilities. Web systems are particularly vulnerable due to their level of exposure. They're available through the internet, accessibility available through the internet, and rapid rate of change. Now, some web systems are somewhat static, but a majority of them are very, very dynamic. Security misconfigurations can happen at any level of the application stack. So we could have a security misconfiguration at the platform level, the web server level, the application server level, the database, the framework, and the custom code. So it's very important that system owners and developers and system administrators work together to ensure that the entire stack is configured properly. We only need to have a vulnerability in one of those areas to make the whole system available for exploit. As a security professional, it's very important to recognize what the top web vulnerabilities are. OWASP, which is the Open Web Application Security Project, is an open community that is dedicated to identifying web vulnerabilities and mitigating web vulnerabilities with the goal of really writing secure code from the beginning. The OWASP Top 10 is published every 3 years. We're looking at the 2013 edition here. The previous one was 2010. And these are the top 10 web application vulnerabilities, starting with A1, which is injection, 2, broken authentication and session management, 3, cross-site scripting, 4, insecure direct object reference, 5, security misconfiguration, 6, sensitive data exposure, 7, missing function level access control, 8, cross-site forgery, 9, using components with known vulnerabilities, and 10, unvalidated requests and forward. Now, as a security professional, you are not expected to be a web developer, a coder, or a program. However, you are expected to understand what these top vulnerabilities are, to recognize them, and to know the security implications. I would strongly recommend that you go out to the OWASP site, owasp.org, go out to the OWASP Top 10 page, and you can see we've got the top 10 for 2013, the top 10 for 2010. You can go through the site. It will go through each of the top 10. It will also explain to you what the implications are. So how did they work? What happens? So you can also look individually at each one of these top 10s. See if I can get right to the page here. You can see that this is A1 injection. It will give you a brief explanation. And then if you drill down, it will bring you to the page that will tell you what the threat agents are, what the attack vectors, the security weaknesses, the technical impacts, and the business impacts. If you scroll down the page, you'll also get information about how you can figure out if your system is vulnerable to that particular vulnerability. So in this case, am I vulnerable to injection? And how do I prevent it? So you can go through for each of the top 10 and really get a good feel. We're going to look at the top 3, but again, I would suggest that you come back to this as part of your studying and just get a good sense for what the top 10 are. So we're going to look at A1 injection, A2 broken authentication and session management, and A3, which is cross-site scripting. So injection occurs when an application sends untrusted data to an interpreter, to the processor. And we looked at process injection a couple of lessons back. The injection flaw is the failure to properly validate input from the client or the environment. So we can inject instructions into a process. And remember that a process has been assigned resources. So once you inject instructions into the process, it will operate in the security context of that process and have access to all of the resources that that process has. A successful attack can result in data loss, corruption, compromise, denial of service, even a complete hostile takeover. Injection flaws are often found in legacy code, very prevalent still. You may have heard injection flaws in areas such as SQL or LDAP or an operating system command or even SMTP headers, but SQL injection is probably the most common. The attack is mitigated by good input and output validation. Number 2 was broken authentication and session management. So in this scenario, the attacker uses leaks or flaws in authentication or session management functions that could be exposed passwords or accounts or session IDs to impersonate a user. So when we say broken authentication and session management, it just means that they're not tight, that there is a way to exploit or a way to have visibility into the authentication and session management controls. So the flaws may allow some or even all of the accounts to be attacked. You may be able to get in as one user, but in essence then start expanding that out and exploit all of the accounts. Such flaws may allow some or even all accounts to be attacked. And when successful, the attacker can do anything the victim could do. So very often in broken authentication and session management, it's going to be privileged accounts that are targeted. Because if you can impersonate a privileged account, someone who has administrative access or super user access on a system, at that point you have elevated privileges and rights to do whatever that account could do. Critical security design requirements must include strong authentication and good session management controls. Highly recommended control for protecting authentication credentials and session IDs is encryption. The third vulnerability we're going to look at is cross-site scripting. Cross-site scripting, which is often abbreviated as XSS, is probably one of the most prevalent web application security flaws. XSS occurs when an application includes user-supplied data in a page sent to a browser without properly validating the content. So attackers can inject malicious code into a vulnerable web application or into a back-end database, and then that malicious code will execute in a victim's browser. So when the victim visits that site or accesses that database, that code is going to come down locally and execute locally in their browser. That'll allow the attacker to hijack the user sessions because now they're in control of the user browser. They could steal cookies, they might be able to execute malware, or they could bypass other access controls. This attack is mitigated by separating untrusted data from active browser content. All of these vulnerabilities that we just looked at are preventable. The issue is whether we deploy secure code or insecure code. Now, insecure code is sometimes the result of an amateurish effort, but more often than not, it's the result of a flawed process, competing priorities, or a rush to market. Secure code is the result of a deliberate process that prioritizes security right from the initiation of the project and continually tests and validates all the way through the development cycle. In Lesson 8, we're going to be looking very specifically at the development process for secure code. We do want to make sure that our developers, our programmers are well trained, and that they are doing security code best practices, which includes ensuring that there's input-output validation, that there is parameter checking, that there is filtering, and that there is code testing. Again, we're going to revisit these concepts in Lesson 8. So all of this may roll up into an application development policy. Remember, a policy is a high-level governance document really that sets the tone for how the organization is going to behave. So an application development policy should include the following statements: that security requirements must be defined and documented during the application development initiation phase, that code development will be done in accordance with industry best practices, and that developers will be provided adequate training, resources, and time. All code to be developed or customized must be tested and validated during development, prior to release, at release, and very importantly, whenever a change is implemented. So that brings us to the end of this lesson. Let's do a lesson review. We started the lesson talking about web vulnerabilities. We looked at the OWASP Top 10. That's owasp.org, and I strongly suggest that you visit the site, that you go look at those top 10 and you read through the top 10, not as much from a coding perspective, but from a security and business perspective, so that you're familiar with the terminology and with the vulnerabilities. We looked at injection flaws, we looked at broken authentication and session management, as well as cross-site scripting, which you'll often see as XSS. We discussed the importance of deploying secure web code and why secure web code isn't always deployed. And lastly, we looked at how we could take all of this information and put it into an application development policy or a governance document. So that brings us to lesson 3.7, match the meaning. We've only got 5 here to do. An injection flaw, broken authentication, a session ID, cross-site scripting, and OWASP. So go ahead and take a few minutes, put me on pause, match the meaning, come on back, and we'll do them together. All right, let's take a look at lesson 3.7 terms. An injection flaw is when we fail to properly validate input. It means it allows us to input instructions into a running process. So failure to properly validate input is what allows that to happen. Broken authentication could be poor credential protection. That's one component of broken authentication. A session ID is a token or value that identifies the requester. Cross-site scripting was a website injection that executes in the browser. And OWASP is a community dedicated to web security. Remember, they're at owasp.org. So we'll end our lesson with 3 CISSP exam tips. SQL and LDAP queries, operating system commands, XML parsers, and SMTP headers are all vulnerable to injection. Encryption can be used to protect authentication, credentials, and session IDs, and that secure code is the result of a deliberate process that prioritizes security. Thanks for joining me for this lesson, and I look forward to seeing you in the next.